You probably have noticed that taking the derivative so far has been a pretty tedious process, and there's got to be some shortcut. Well, you are right. Mathematicians have, through doing so many derivatives, have come up with some different patterns that actually work. So today, we're going to be starting to learn some rules. So at the end of this lesson, you'll be able to apply basic differentiation rules to find the derivative of a function. Let's start out with a constant rule. If c is a real number, then the derivative, d dx is just another way of saying the derivative, is equal to 0. And in plain English, the derivative of a constant is 0. And I'm just going to show you that just real quick here. Let's say the derivative of a constant, so I have a constant function, so let's say I have the function f of x equals 2. That's a constant function, that's a constant 2. If I looked at the derivative, or the slopes of the tangent lines, the slopes of each tangent line that I could draw has a slope of 0. That's why the derivative of a constant is 0. So let's just try a few examples. If I have y equals 4, and they ask me for y prime, since y equals 4 is a constant, my derivative will equal 0. If I have f of x is equal to negative 7, when I take the derivative of a constant is again 0. And then s of t equals 3 pi. Notice that there is no t in this equation. Pi is just a constant. It's 3.14159 something something something. So since 3 pi is a constant, the derivative ds dt is also 0. Right, another rule is the power rule. If n is a rational number and f of x equals x to the n, then f prime of x is equal to n x to the n minus 1. Basically what's happening, if you have an x or something that's raised to a power, we're going to take the power out front, then decrease the power by 1. So some examples involving that. When I have f of x is equal to x to the 7, when I take the derivative of that, so f prime of x, we're just going to bump the 7 out front, and then we're going to subtract 1 from the power. So now it will be 7x to the 6, and that will be the derivative. And then this next one, notice before I do this, I don't really see a power, so we're going to actually make a power. So we're going to rewrite the problem. I know the 4th root of x is actually equal to x to the 1/4. And now when I take the derivative of that, I'm going to bump the 1/4 out front. Oops. So I'm going to get f prime of x is equal to 1/4 x. And then remember, we're going to reduce the exponent by 1, so we're going to do 1/4 minus 1, and that will equal negative 3/4. One thing that I'm going to do with this, and I'll have you start doing this because when we go to solve them, it's not very convenient to have a negative exponent. Most people aren't very comfortable working with negative exponents. So I'm going to make that power positive, and if you recall, to make a power positive, we can just move it down to the denominator of the fraction. So I'm going to rewrite the problem to look like this. So the 1's going to stay on the top. I'm going to have the 4 in the denominator because that's where it is now. And then I'm going to move the x to the denominator with it. And notice when I do that, it changes it to a positive 3/4 power. So that is my derivative. All right, let's do a few more examples from that. This first one, you'll notice I do have a power, but I also have a fraction going on. So what I'm going to do, opposite of what I did in the previous example, if I have an x down below, I can bring it up top and make the power negative. So another way of writing this would be f of x is equal to x to the negative 5 power. And I could put that 1 there if I really wanted to, but not really necessary. So I have f of x is equal to x to the negative 5th power. Now that I have a power, I can use the power rule. So I'm going to have f prime of x is equal to, I bring the negative 5 out front, I still have my x, and then I'm going to subtract 1 from that power. So negative 5 minus 1 is negative 6. And then again, we are going to get into the habit of not keeping negative exponents. So when I go to rewrite this, the negative 5 stays up in the numerator. I bring the x down to the denominator, and the power goes from a negative 6 to a positive 6. Right. In this next example, again, before I start working the problem, we need to take care of some issues to make it look like something we can use the power rule on. First of all, the square root would be x to the 1/2 power. And then from here, we don't want it to be a fraction, we just want it to be a nice looking number. So we're going to bring the x up top, and if I bring it up top, it will become a negative 1/2. I'm now ready to take the derivative. So we're going to bump the negative 1/2 out front, so we'll have negative 1/2 x, and now we'll subtract 1 from that power. So negative 1/2 minus 1 would be negative 3/2. And then from here again, we do not want negative exponents, so let's rewrite it. The negative 1 gets to stay on the top. The 2 is down in the bottom, so it's going to stay in the bottom. And we're also going to put the x down there, and now it becomes a positive 3/2. So that would be the derivative of that function. Right, one more rule is the constant multiple rule. If c is the real number and f is differentiable, remember differentiable just means you can take the derivative, then the derivative of a constant times that function is just the constant times the derivative. So basically in plain English, we're going to find the derivative and then multiply it by the constant. You'll kind of notice this is pretty much just common sense as we're working through the problems. All right, so we're going to find the derivative. When I go to find the derivative, we are going to, again, since I have a power, we're just going to bump that power out front. And you'll notice I have a constant out there. So basically, we're just going to be multiplying the 4 and the 3 together. So when I go to take the derivative, 3 times the 4 is going to be 12x. And then we'll subtract 1 from the exponent, and we'll get 12x to the second. That is my derivative. Okay, this next one we would like to rewrite it first, so I'm going to put y equals 7x to the 1/2, and now we get to use the power rule and the constant rule, I guess both of them kind of at the same time. So we're going to multiply right in front of there. 7 times 1/2 will give me, let's see, 7 times 1/2 will give me 7/2, there we go, x. And then when I subtract 1, 1/2 minus 1 is negative 1/2. And then I'm going to rewrite that. The 7 will stay up top. The 2 belongs down in the bottom because that's where it is now. And the x down in the bottom will now turn to an x to the 1/2. And I'm actually going to go one step farther in this because I know anything to the 1/2 power is just a square root. So I'm going to rewrite it as 7 over 2 square root x. So that is my derivative. Whoops, all of those I should have had a y prime because I was taking the derivative. Right, a couple more examples here. Let's say I have s of t is equal to 4 over 5t. We have an issue because this t is down here and we don't need the t down there. We actually want it up top. So what I'm going to do is 4/5 is actually just the constant. So when I go to rewrite this, just watch how I rewrite it. I'm going to write it as 4/5 t to the negative 1. Okay, so now notice we have 4/5 hanging outside, and then we have t to the negative 1, and we're ready to go ahead and take the derivative of it. So now we're going to bump the negative 1 out front. Negative 1 times 4/5 will be negative 4/5 t, and then I'll subtract 1 from that power. Negative 1 minus 1 is negative 2. And then again, we have a negative exponent, so I'm going to rewrite it one more time here. The negative 4 stays up top, the 5 stays on the bottom, but it gets to be joined by the t. That becomes a positive 2 power, so that will be my derivative. Okay, let's try one more example here. Again, before I take the derivative, we would like to rewrite this function as 8 over the 4th root is the same thing as x to the 1/4 power. And if I rewrite that, it will be 8x to the negative 1/4. So when I go to take the derivative, we'll bump the power out front. So we'll have negative 1/4 times 8, which gives me negative 2x. I'm going to subtract 1. Negative 1/4 minus 1 is negative 5/4. And now we're just going to take care of our negative power. So my derivative will equal the negative 2 will stay up top. My x moves down to the bottom and becomes a positive 5/4. So that would be my derivative. So hopefully now you can take the derivative using some rules.